All right, so there's a game that I found in an old book that someone gave me once. Actually, I think I took an office, and it was full of the previous tenants' stuff. And I started going through, and there was a book from like 1981 called A Hitchhiker's Guide to Artificial Intelligence. And I meant to bring it with me today. It's this really bad pixel art on the front, and all of the references to the resource limitations. If you have 1 megabyte of RAM, this is what you can do. This kind of situations. But the underlying problems are exactly the same problems as we have now, right? The techniques, the kinds of things. It's just that certain things we can do better now, but we still have the new limitations on it from that. Well, there were two authors. And one of the authors, I think his name was Forsythe, and in the text, they invent a game, which I have never seen mentioned anywhere else, other than in this one book. But Forsythe they built on Tic-Tac-Toe to talk about an AI for Tic-Tac-Toe. And then they said, okay, well, what happens if we extend the game a little bit? And they gave some examples of other ways to extend Tic-Tac-Toe. And one way to extend Tic-Tac-Toe is a game that they call Foresight. Foresight is kind of like Connect 4, trying to get 4 in a row. But in Connect 4, there's gravity involved. Right? So here's what happens in Foresight. I think they number them 1 through 6. Actually, they draw it in a different way. Anyway, but the idea is here. All right, so what you want to try to do is you want to try to get 4 in a row, vertically, horizontally, or diagonally, either way. All right, but here's how a move works. Let's say you're player 1. You're player 1, you pick either a row or a column. All right, so somebody pick a row or a column. Just C. All right, so you say C, and the other player then gets to tell you which column. So I say C4, and you have to play. I shouldn't have used that letter, right? It was just for your initial, but you play an X here. Since it was like tic-tac-toe, you play an X, I'll play an O. Right? So you played an X. So your move is based half on what you say and half on what the other person says. All right, so now it's my turn. And I say 1. So I have to play, you said E? All right, so I have to play there. And it goes back and forth like that. Right? And so what happens? You are trying to get 4 in a row, but you're trying to block me from getting 4 in a row. And I'm trying to do the opposite, right? I want 4 in a row and try to block you. But each move depends on partially on what you do and partially on what the other person does. And so you can see that could be an entertaining, possibly a 2-player game, but also trying to create an AI that would be able to play that game well. Is there a way to do this with a genetic algorithm? Possibly, somehow, in terms of scoring things based on, okay, I've made this move at this point and this move at this point, but probably not, right? This is probably not something, because how you get to a solution matters here, and what happens in the problems that we've seen so far with the genetic algorithm. All that matters is what is the solution, right? But how you get there matters in this case. It's probably not easily or not really set up to be attacked in this particular way, but I just really like this game and think that it's an interesting thinking through what the other player can do and what they would probably do.
What was the game Wouldn't there be a strategy of just keeping the same level no matter where you're at? So like if like the other person was C, no matter what, they would just keep calling C because that would limit the person's numbers of range. So they would always get.
So now it's your turn again, and you're going to say C again?
Yeah.
All right. So what might I do? Maybe I say 0. And now then what could I do?
C.
I could say C.
Oh, okay. So that's what I was wondering. I didn't know if you were only on 0 to 5, and the other person's on the other.
No. So at each time, you get to choose a row or a column, and then the other person fills in the other half of it. So if you said C again, and I said this, then I'm going to say C this time to break it up for you. But yeah, if you got to only put in rows, and I get to only put in columns, then what happens? Whoever goes first would be able to win that, right? But the situation is you pick half of your solution, and I pick the other half for you, or your location where you're going to put it. And so, yeah, you can switch back and forth. You can pick a row, or you can pick a column, but whichever you pick, the other player picks the other half of it. All right? So I think there's interesting aspects to it. I've never really explored it very far, other than just playing it a few times. I think I had maybe one student who started to analyze it from an AI point of view and kind of ended up doing a brute forcing their way through a bunch of things. And so there'd be more elegant kind of solutions, more elegant AIs to play this game. And you've all seen Ultimate Tic-Tac-Toe, which also uses something that the other player. Everyone's seen that game, right? I think so. When you have if you play, say, an X here, then that means that the other player has to play in the bottom left-hand grid. So if they play an O here, that means that the X has to play up there. If they play an X here, then the O has to be in here. The X would have to play in the right-hand side, and goes around until, again, the goal is to win 3 subgrids in a row, which I played this game for the first time in a long time this morning and lost. So what happens? There are strategies to this as well. And there are things that happen in this particular game, right? If you've already won one of the subgrids and somebody sends you to that grid, you get to play wherever you like. There's extra rules to that game. But it's a similar kind of idea of the other player is telling you something about your move. And in this case, the other player tells you half of your move. You say the first half, they say the other half of it. In this one, they tell you where you have to go first, and then you make your choice inside that subgrid. So these are more interesting versions of these 2-player games. Instead of just my move being completely determined by me, the other player has some control over that move. So think about these. Think about that in particular. It's not going to be on the quiz. The quiz will, again, cover genetic algorithms only. All right, so let's use the time that we have left somewhat efficiently to ask questions or to make some progress on the labs.